For 20 years, bipedal robots were confined to the museum era. Honda's Asimo proved a machine could walk, but it existed strictly within the confines of million-dollar research budgets. By the 2010s, platforms like Boston Dynamics' Atlas proved a robot could move like a human athlete. Yet these highly advanced prototypes were funded almost entirely by massive defense budgets. That academic reality shattered between 2024 and 2026. The industry entered the price break era, turning experimental prototypes into commercially viable industrial commodities. In May 2024, Unitree launched the G1 Humanoid at a starting price of $16,000. 14 months later, in July 2025, they released the R1 for $5,900. These 2 years mark the historical threshold where the physical body of the bipedal robot was finally priced for the factory floor. A bipedal machine presents a unique engineering paradox. Previous industrial robotics could specialize in a single task, but a humanoid requires simultaneous solutions for balance, vision, and environmental interaction. This master equation requires compressing silicon, memory, power cells, and actuators into one unified frame. Remove a single factor, output drops to zero. Engineering this complete stack into a 35-kilogram weight limit at a sub-$6,000 price requires an entirely different manufacturing ecosystem. To understand how the price floor dropped so quickly, we have to map the geopolitical supply chain building these machines. When you tear down the components, you find a permanent physical geographic split between the brain and the body. Tesla Optimus holds the largest ambition in the West, targeting a production volume of 1 million units per year with deep vertical integration. But stated ambition diverges from actual physical shipment data recorded over the full year of 2025. This bar chart tracks the 2025 market. Across the industry, only 13,000 to 20,000 units were deployed. Agibot shipped 5,168 units. Unitree delivered 5,500. Tesla, Figure, and Agility shipped 150 each. Chinese firms captured 90% of the global humanoid market. Western analysts frequently dismiss this Eastern volume as unprofitable prototyping. The verified financial data contradicts that assumption. Unitree's July 2026 IPO prospectus revealed that their humanoid revenue had surpassed their quadruped robot revenue for the first time. Across those product lines, they maintained a verified combined gross margin of nearly 60%. By mastering the components, the East has turned the physical humanoid body into a high-margin, scaled manufacturing reality. This 3D teardown maps TrendForce's 4 cost planes. First is the mental plane, accounting for 25% of the total cost, housing AI training, system on chips, and machine vision. This upper plane is the undisputed Western fortress, supplied by NVIDIA, Qualcomm, Siemens, and Mobileye. This section houses the machine's brain and the highest margin intellectual property in the entire stack. The West successfully commands the intelligence and the real-time decision-making capabilities of the hardware. But a world-class brain cannot move materials. 75% of the cost lies below the neck. Moving to the movement plane, the limbs and chassis account for 55% of the total cost. These specialized parts, precision motors and drives, are overwhelmingly led by the East, anchored by Chinese suppliers Hengli and Xiaowei. The remaining cost splits between the sensing plane at 11% and the power plane at 9%. The robot's metabolism, battery cells, and cooling is completely controlled by Eastern giants CATL and BYD. This split creates a total hardware dependency. Ultimately, a Western-brained robot is fundamentally designed to walk on Eastern screws and draw its current from Eastern battery cells. Disentangling this supply chain would require a ground-up engineering redesign, a process that cannot be completed on a 2026 timeline. Why did the price floor break in Shenzhen and Hangzhou rather than Austin or Munich? The cost collapse is a direct result of iteration rate, the speed at which hardware is redesigned and machined. This timeline compares the traditional Western prototype cycle against the Eastern model. Building a sub-$10,000 arm in the West takes 14 weeks and costs $25,000. In Shenzhen, that exact turnaround requires 14 days and costs $8,000. Manufacturers achieve this because component suppliers are located within a strict 2-hour logistics radius of the assembly lines. That dense geographic clustering was built to serve the electric vehicle industrial base. The actuators, precision motors, and battery cells developed for cars are transferred directly into humanoid production lines. In young hardware sectors, iteration rate is destiny. China's EV base guarantees the highest iteration rate on Earth. China's current industrial advantage is the result of a coordinated national program. China's Humanoid Robot Action Plan established a hard national target: 100,000 deployed humanoid units by 2027. At the 2025 and 2026 CCTV Spring Festival galas, domestic humanoids performed complex parkour routines and autonomous high-speed cluster repositioning. They broadcast these highly coordinated hardware demonstrations to an audience of hundreds of millions. The broadcast served as a clear geopolitical signal. The humanoid body is a formalized national program, the component chain is domestic, and the state is openly displaying its capability. Ford CEO Jim Farley studied Chinese EVs, imported one to Detroit, and publicly labeled their manufacturing capacity an existential threat. The manufacturing capacity developed for electric cars now builds the humanoid robotic body, utilizing the same actuators and power cells. The foundation is now fixed. The West holds the 25% mental leverage, but the East commands the volume, price, and iteration speed of the physical body. The primary hardware race to build a viable, mass-produced bipedal chassis for the global market is effectively over. The physical body has a price tag. The next era will track the deployment, the economics, and the ultimate dominance of this new labor force.